Antiderivatives. In math, we often learn how to do an operation, and then we learn its inverse, which is how to do that operation backwards. For example, we learn how to add, then we learn how to subtract. Multiply and divide, exponents and logs, trig, like sign, and arcsine. And for us in calc, derivatives and antiderivatives. So let's take a look at what an antiderivative is. Basically, if a function can be an antiderivative, it is an antiderivative of f of x. So capital F of x is an antiderivative of small f of x on AB if you could take the capital F of x function's derivative and end up with the original function. So the opposite of taking derivatives is an antiderivative. And this process of finding an antiderivative is called integration. So let's take a look at an example. Okay, an example or two. If you have an original function of f of x is equal to, say, 14x, then what is the antiderivative? And you have to think in your head, what function would I have where if I took the derivative I'd end up with 14x? And the answer to that is 7x squared is an option. If you take the derivative of 7x squared, you end up with 14x. Try another one. What happens if you have a function of 2 cos x? What's the antiderivative? So what function, if you took the derivative, would give you 2 cos x? Well, the answer is 2 sin x. You take the derivative of that, and you end up with 2 cos x. We can extend this type of questioning and show that there's more than one antiderivative that can actually work. For instance, find 2 antiderivatives of f of x is equal to 2x. So one answer that you might come up with is x squared, because when you take the derivative of x squared, you end up with 2x. But another answer that you may come up with is x squared plus 8, because when you take the derivative of x squared plus 8, you also get 2x. So you'll notice here that there are many solutions. So how do we know which is the right one? Well, if we look back at the last question, it only asked you to find an antiderivative. So find any example that works. For the second one, find 2 antiderivatives that work. But there are many solutions, so we need to have a way of showing that this is our many solutions answer. So let's take a look at that. So some notation for you. The notation in this squiggle here, and then a function, and then a dx means find the derivative, the antiderivative of the function f of x with the variable x. That's the dx part with respect to x. Now it turns out that there are many solutions, as we saw below. So when you do this, you'll end up with a solution, and as long as you add a variable, a constant term, that constant term will always have a derivative of 0. So you could add 8 like we did, or add 6 to that last example, and as long as what you're adding is a constant term, it always turns out to be 0. So the notation, and this is the notation we use, finds the general antiderivative, or the indefinite integral of f of x. Capital F of x plus that constant is the general antiderivative, or we can talk about the integral, and the integral of f of x dx is called the indefinite integral of f of x. So a couple symbols for you. This symbol here is called the integrand, and that little d of x has a special name. It is called a differential. There's also some additional rules that we need to know about antidifferentiation. So let me just put those down and some examples of those. So we know the power rule. There is the antiderivative of the power rule. So instead of going down by 1, you go up by 1. And that works for n can't be equal to -1. And here's an example in blue. If you have x to the 4th dx, you get x to the 5th over 5 plus c. Another rule is for logs, and that just won't work when x is 0, so x can't be equal to 0. There's also rules if you have two functions added together and you take the derivative with respect to x, you can split them apart. So you can take the antiderivative of the first part and you can add it or subtract the antiderivative of the second part. So if you end up having, as an example in blue, x plus 5 dx, you can split this up into x dx plus the 5 dx, and you end up getting x squared over 2 plus 5x over 1 plus c. We'll continue with some additional rules. If you take the antiderivative of a constant times f of x, then you end up being able to factor out that constant. So if you have, as an example in blue, 5x squared dx, you can think about this as 5 and the antiderivative of x squared dx, which gives you 5x cubed over 3 plus c. And there are a whole bunch more rules to do with trig. Let me list those out. There's the first 3 for sine, cos, and tangent, essentially. There's the 3 other ones. Of course, we have a really easy one in e to the x, which is e to the x plus c. If you make the x a little bit more complicated, then that can also be written as, you have e to the kx plus b. You make the exponent a little bit more complicated. Of course, taking the derivative is e to the kx plus b, so that kind of stays the same. But with the chain rule, we have to take into account the fact that there's a 1 over k that it would need to multiply by to kind of cancel out the k value, and then you still have plus c. So an example of that one might look like, let's take the antiderivative of e to the 2x plus 5 dx, and of course you would get 1 over 2, because the k value is now 2, e to the 2x plus 5 plus c. And you can check any of these anytime you want. All you need to do is take the derivative of your answer, e to the 2x plus 5 plus c, take the derivative and see what you get. When you take the derivative of this, it's e to the 2x plus 5. That's not x, so it multiplies by 2, so 1/2 times 2 is 1. The derivative of your constant is 0. These numbers cancel, so e to the 2x plus 5, which is the number that I wanted to take the antiderivative of. So you can always go back and check. There's another type of question that eliminates the plus c in a certain way, and it's called an initial condition question. And it looks like this. Find or solve this when your y dy over dx, which is like y prime is equal to 3x squared, when x is 1 is equal to 5. So this is your initial condition. So we take an antiderivative of 3x squared. That takes us from y prime to y. And so the antiderivative of this is 3 times x cubed over 3 plus c, which is just x cubed plus c. But that's our y value. But I now can apply this other information and solve this initial condition. So I know that when x is 1, y is 5. So for this particular case, there is a c value, and the c value is 4. I can use that to calculate the actual formula of the initial condition, given the initial condition, that still gives us a derivative of 3x squared, but also takes into consideration the fact that when the initial condition x is 1, y is 5.